Oh, well, hello and welcome back. As usual, we'll wait a few more minutes, give people a bit of a chance to join us, and we'll get it started. So, see you in a second. Alright, let's get started. Super excited here. So, as usual, I usually start with a quick recap of what we're doing, where we are. So, kind of grounding us to how things will go. So, this whole series is dedicated to building Notion backend. And I use Notion a lot, and I keep try to think about the tools that I use. And when I'm using Notion, I discovered that there's tons of interesting challenges that we can learn from. For example, things like collaborative editing. How does that work under the hood? And that really piqued my curiosity. And also, how can you be editing something in Notion and you suddenly find it on your phone, and have multiple people editing simultaneously and you can still find it on your phone? This is pretty interesting, and it's not an easy problem. If you're modeling it over like two users, then yeah, it's not really a big of a deal. But to have that many numbers of users like as Notion, it's damn interesting, and I think we can learn so much from it. And this is exactly why I started this whole like series. Is like, let's try to uncover all the little bits and pieces and try to make sense of everything we do, not just from a theoretical point of view, but also from a true implementation. And I think this is extremely important because you've got on one side some tutorials that kind of show you how to get something done, and then you see another tutorials that are kind of theory focused, but then there's a huge gap in between that I don't really see a lot of people covering it. And I think this is a chance for us to do that because we've already gone through some data structures, we've already gone through some DDD modeling, and now, and last time we started talking about transactions and a bit of these issues, and today we're going to be talking about Neo4j and Cypher, and this is going to be the database that we're going to use. There's few reasons why I think it would be interesting to use it. One, it is NoSQL, so I don't really have to teach you SQL right now. Two is because the nature of the document is segments, in our model at least, then it kind of makes sense for these segments to be an object of their own. And to do that in SQL or any table-based database, right, you'll end up having to create like weird normalizations that I don't think we should deal with. So that leaves us with the other alternative, which is NoSQL databases. So that involves whether like document-based databases, and this could be like MongoDB and a bunch of others, or you can go to like the graph databases. So for Mongo, you'll have to nest relationships, and I do think we will have tons of relationships because in Notion you can do things like tagging people. You can have multiple people allowed to a certain thing but not the others. So I really think that if you do this with a graph, your model is much simpler to deal with overall. And we'll see. We're trying to implement it in a way that we can change the underlying database at any time. It's ambitious. A lot of projects don't do that, and a lot of others do as well. So let's see how that goes. And the one last thing we did last time that was pretty interesting as well is we went through the create document, and we actually started like creating it through the repository. So we did the first test, which was here. Let me give me some space here so you all can see the entire structure of everything. All right, cool. Okay, so yeah, we did the create document test, and we did talk about the table driven test, and that kind of took most of the stream because we discovered that we need to do a bit more than just like saving a document in a map, right? We needed to like find another document and add it. Anyways, let's actually get to the database side of things. Of course, there's the videos on YouTube. You can always go and revisit them. All right, so what is a graph? Let's start there. Well, I'm gonna draw a bunch of nodes, then I'll talk about it so it's a bit more coherent. All right, so first off, we need to understand some terminology in a graph, right? So the first thing we have is called a node. And a node is essentially the thing in your graph that you want to represent. So that could be a user, that could be an address, it could be a location, it could be a restaurant, it could be really anything that you want to say, hey, this is an entity that I have, and I want this entity to have some properties. And if you're coming from an OOP land, then you can think about the node as essentially an object that you want to keep. So that is one thing. So that is the first thing that we need to know. That's a node. Excuse me. All right, so if the node is an object, we need to have relationships between these objects. So usually you will have like a one direction relationship that kind of says that this relationship here means that they are collaborators, or like user 1 invited user 2. Okay, and let's now give them a name because we now know that these are entities. Okay, so again, these are nodes, and this here is called a relationship. right? And now another thing that we need to know, what is an edge? So that line right here is what is known as an edge. And an edge is the connector that carries the relationship. So when you're doing basic graphs in like a data structure course, typically you don't care too much about the relations unless you're doing a bit more of quote unquote advanced data structures where you have to care about the weighted graphs. So let's talk about undirected graphs, directed graphs, weighted graphs, and we'll get back to the Neo4j because these concepts transfer really well. And I think if you understand the basics of graphs, it kind of makes a lot of sense when you're dealing with the database. Right? It's not a mandatory requirement, and maybe I'm getting a bit deeper into it now than necessary, but hey, guess what? That's why we're here, to level up. So stay leveled up. Okay. Again, so here is let's say this is Toronto. Okay. And now you have another city called Oakville. And another city called Vaughan. So these are all now are modeling cities, right? And now these graphs have no relationship whatsoever as of now. Now, if you connect these graphs, what you can do is that you can say, here, I'm gonna connect this with this, this with that. So now there is a path between Tron and Vaughan and Toronto and Oakville. However, there is no direction. So there is no direction involved in this graph, which makes it a bit harder to deal with because you don't know if this is a bidirection or is it one way. But typically, when it's an undirected graph, you can go from one way to another. So in a sense, you can go from Toronto to Vaughan, Vaughan to Toronto, Toronto to Oakville, Oakville to Toronto. Okay, so now you understand undirected graph, which makes it extremely obvious now what a directed graph might be. So that becomes a directed graph just for the mere fact that there is directions. So here what we're saying is you can get from Toronto to Vaughan and you can get from Oakville to Toronto, but you cannot get from Vaughan to Toronto or Toronto to Oakville. I said Toronto way too many fucking times. But I hope you get the idea. So a directed graph has a direction. Now, we added one more thing now, which is called a weight. So this graph might have some properties, and these properties could be a distance. So let's say from Oakville to Toronto is like 100 kilometers, right? And of course, these numbers are like bullshit, but you get the idea. So now, this graph now have a weight for it. So you know that from Oakville to Toronto, you need to drive 100 kilometers. So now you can make sense of not only the direction, but you can account for the weight. Why is that helpful? Because now, assuming there's like, I don't know, there is another city in between, right? We're just gonna call it X. There's an X city in between. And you know that you can go from Oakville to that city and you can get from that city to Toronto, right? And let's change the direction to be a one-way. So here, and no, we want this. Boom. Okay, so now let's say you can go from here like 60 kilometers to this X. I'm trying to switch the direction of this thing. and this direction here, let's say actually this is the 60 and this is the 10 or 20. So now, because you have this weights on the graph, you can make much better sense of the decisions. For example, one solution is like, well, I need the shortest path to go to Toronto. What should I do? Well, you can either go the 100 kilometers, but there's a shorter route that involves more hops, but it's still overall shorter, which is from Oakville to X, which is 20 kilometers, and from X to Toronto, which is 60. So you get a total of 80 kilometers and you save the rest. So this is the basic concepts of undirected graph, directed graph, and weighted graph. So what is Neo4j then? Well, Neo4j was like, okay, we have all this graph stuff. Why aren't we utilizing it to store data and be able to get relationships and be able to understand what's happening within our data in a much better sense? Because in real life, everything is almost like a relationship. You own a home, you're renting a home, or you have a friend and that friend has a friend and you have the number of that friend. So now you can start making sense of a lot of what's happening just by looking into your model and trying to analyze it. And it's also very extendable because in SQL, you will need to make changes to the table. You need normalization. You need a lot of heavy schema and definitions before you're able to like do anything that is truly useful, right? Versus in graph, you kind of say like, well, you know what? I have two types of users now. I have legacy users and new users. Well, okay, well, you can model a legacy user as an entity in itself. You can imagine like how useful this is in things like Facebook or social media in general, because in social media platforms, it's really based on discoverability, right? This person shared your post, you became super popular, you became a superstar, so someone shares your post and people are liking it and commenting on it. So you can imagine there's like a life of everything that you do as a node and all the relationships in between. So another thing that we need to understand now is that in Neo4j, it's all about directed graphs. And it's also a unidirectional graph. And this is true, but there's a small caveat to that. So you can actually traverse. A word traverse is just a fancy word to saying go from point A to point B. However, this is like one of the most used words whenever you're talking about data structures or you're talking about graphs, specifically trees and graphs. So if you want to traverse, you can traverse from user 1 to user 2 and backwards. But when you're defining your relationships, you must give a direction. So yeah, keep in that mind. You must keep a direction. Okay, now, so now we learned what a node is. We learned about what a relationship is. But what other things that Neo4j add to us that we wouldn't have in like a basic graph? Well, another thing is nodes in Neo4j have properties on them, which means that they have actually properties and a label. So label and properties. So let's start with the label. The label is what you classify this node as. For example, this user 1 here, it's a user, right? So it could have a label of user. But let's say this user is actually a premium user. So we can give like a premium label to him. So now when we're looking for entities in the database, we can use any labels we want to get the data back that we wish. This is really cool because you can have a user who's a premium, but you can also have like a user on free trial. right? And now you can easily check if this user have permission to do everything the premium user does or whatever. So actually, this kind of works out pretty nicely. So the premium user has invited a user on free trial right now. Great, it kind of makes sense. Okay, so this is what labels are. Now, what are properties? Oh, I actually noticed that this might be tiny for you. Damn. And maybe I can organize this a bit. Of course. Okay. All right, so properties is the content that you want to store in this node. So for example, a user might have username, an avatar picture or profile picture. He might have a contact info, right? So these are the properties that you want to store on the database for each of these label types. And now, when you go into the relationships, you can see that relationships have a name. And there's a convention in Neo4j is that your relationship are all uppercase. And that kind of simplifies when you see it in your code, that you see that whenever there's an uppercase, you associate it with a relationship. Now, another best practice about relationships is you kind of want them to make sense. So you don't want to say user one and give a random name to it. So you want to be able to read it fairly as a sentence to the best of your ability. So you want to say user one invited user two. That reads like a true sentence, right? Or user one created a document. So here we can create a line. Great. But now relationships also have properties. However, it's not really recommended that you store information on the relationship itself. So try to keep it bare minimum for you to know, like, this user has invited this user. That is almost enough information. You might add a timestamp if that will help you, sure, but don't abuse it, please. That's what even Neo4j would recommend for you. Great. So now what? All right. So now let's talk about how can you possibly query all of that. By the way, guys, you've just learned tons about Neo4j in that simple model, and that's kind of speaks volumes about what graph databases are. Of course, this is still a shallow introduction, and through this stream you will learn much more, and even today alone you'll learn a bunch of Cypher that will make your life much easier. But you've learned the basics of the graph, right? This doesn't translate the same for tables with there's this primary key that goes to the other table, or secondary key that points somewhere else, and you start getting dizzy by all these relationships in SQL or on SQL databases, just because you have to do a bunch of random breakdowns. Versus here, this kind of what's your model and how you want to represent it to something that makes sense and efficient. So here you go. All right. So now let's go learn some Cypher, and we will get back to our actual problem space, and we'll work out what the model is like for something like a document in Notion. All right. First off, Cypher is an ASCII art. Okay, so what does that mean? Well, ASCII art is like, if you want to do a smiley face, you do like that, right? If you want to do like a sad face, you'll do like that. That is like someone wearing glasses, I think is 8 and smiling, right? And you take the same concept but for graph. So here is a node. This is just simply a node. And this is a relationship between nodes. Cool, eh? So now, if you want a node with a label, actually I'd like to make it a bit of an extra large. So here you can say a user, and here's the relationship linked to another user. Okay, so now what? What if I want to specify the relationship? Then I can just put these brackets and say invited another user. Now let's say we want to model the relationship between this user one who created the document. Well, similar thing. So here, created and a document. What about the fact that this user is also a premium user and this one is on a free trial? Well, I can also do that. So I can say user premium and invited. There's another user, but on free trial. Pretty neat, right? And is the basic syntax for Cypher. How amazing is it that you're able to learn this that quickly? Of course, if you see this without anyone telling you what this means, it's a bit confusing in the beginning, but it's not really that hard, right? Okay, let's explore a bit more things. So now, if I want to add the properties to the user, you just create like this JSON object kind of thing, and you say name Omar and address somewhere or internet. Okay, and that's it. So that is modeling a node with some properties. So here you learned about a node linked to a node. You added the relationship. You saw the different types of labels. You've seen combining multiple labels, and you've seen adding properties, right? So now, what about adding properties to the relationship? Well, that is not really something that you can draw. At least, I'm not really sure about that. So yeah, so I was just looking up if you can actually draw the relationship like properties like right here. And you can't really do that, right? But we will learn how you do it. So just with this ASCII art, you can do shit ton of stuff. Because also another thing that you can do is, for example, you can say, hey, I have this user, but I want to connect it somewhere else with a relationship. I don't really know its name yet, but it's linked to another, to like premium user. And I misspelled premium, but right here, so I don't have to copy it. Great. I don't know if you realize how awesome that is. Okay, so now we need to learn about some keywords to be able to work with these ASCII art. And I'm gonna go to the Neo4j workspace, you can go to something called Neo4j Aura. That's a hosted Neo4j. So rather than running your own Neo4j locally, they run it for you as a service and you get a free tier. So go check it out. It's pretty cool to like run a Neo4j node and just like be able to work on it straight from the web. But if you feel like it, you can also download it in Docker. There's an image for Neo4j and you can spin it up. I'll get actually into Docker and Kubernetes and all this fun stuff. By the way, these are the areas of my expertise. So I've worked as a senior software engineer, especially in infrastructure. So I've got so much to say about these topics, but I wanted to explore our back-end skills first, and then we'll get into like the full workflow, and I'll show you even like how to do local development without using a service like this. But for now, to focus on learning Cypher, this is a great start. Magnificent. All right, now what? So now we want to be able to find everything like on the database, for example. So I can do match, and the match is what's equivalent of a select, right? Now we said that these brackets here, I don't know if you can honestly see this, so I'll try my best to like get you to see this. I might just expand it a bit, even more, maybe 200-300. Yeah, that's, I think that should do it. All right, so now okay, so now we have our match and we want to match everything in the database. So what you can do is you can also give variable names for these nodes. So we looked into like something like user, like sorry, that was a slip. You looked into something like user here, right? But now I want to give it a variable so I can reuse on my Cypher query. So you say match user. So now I give it the variable u to refer to the user node. And now I can just say return u. But I want you to notice something here, right? By the way, I've already created these users, so don't worry about it. You'll learn how to do that for yourself right now. Okay, let's have a look into our queries here. So now you're saying match the user label and give it the variable u and return the u. Okay, what if I want to return everything in the database? Well, I can say I'm gonna name my variable n, and this is just a convention. Name it whatever you want, and just say return n. So now you return everything on your database right here. Okay, great. Now, what if I want to return things that are connected to each other? So I can do this, and let's say n2, right? So these are everything that is connected to each other. But let's say you want to actually see how are they connected. So you can also give a variable to the relationship, and you say are. And here you go. You see how these things are connected. Mind you though, that here we're really matching any node with a relationship to another node. Okay, so another way you can do that is you can say, I believe you can do like a star. Yeah. And now you're saying like, give me any two nodes with any numbers of relationship in between. Okay. Now, let's go and look into Carla, right? Let's say we want to explore more about this person right here with their documents and everything. So now let's write a bit more specific queries. So I'm gonna say match, right? We know how to ask for a user, so this is a user, but let's give it a variable if we want to return information from them. And I want the user with the name Carla. So I will say name and Carla, and now return the user. And here you go. If I double click on it, I'll see the first relationship. But if you drop down this, you'll see that the node only have an ID and a name. I want you to notice though that this ID, the one between the less than and greater than signs, are generated automatically by Neo4j. And it's not a good idea to depend on the consistency of that ID. At least to my knowledge, and I've read that somewhere. I'm not sure which book, but yeah, I read about that you cannot guarantee this ID, similar to like SQL, for example, where like you can generate an ID and depend on it. So if you're gonna be using IDs, generate your own and store it, because this ID can change when you modify the nodes. Okay, so now let's say I want to discover all the documents that Carla has, right? Well, what can I do? So we know that Carla has a root document. Okay, first off, let's figure out all the documents that she has. So we'll do the relationships, and here I'm actually not gonna specify anything, but I'm gonna say document, and I'm gonna give it the letter D and return the D. So here we see only the root document, right? So what about if we do this? Okay, so what happened here? Let's go back first to show you what happened. And here we return the first connection with Carla. So we said, hey, there is our user. Her name is Carla, and she has a document, a direct document connected to her. And indeed, so it returns the root. But that's not the question that I asked. The question I asked is, what documents does Carla has a relationship with, no matter how deep these documents are? And because of that, I don't know how deep it will be, so I can just say any number of hops. So now I get all these documents that she has. Okay, now what if I want the count of her documents? So I can just say count documents as document count, and here you go. So we have some built-in functions to Neo4j that you can use, and you can actually even extend these functions by using a tool called Apoc, but we're not gonna get into Apoc today. And I believe actually Apoc is now like part of Neo4j, but you can always install different plugins essentially to use their functions on your data. So anyways, so the count counts the number of returned documents here, and we just gave it a title called document count, and this is what we got here. All right, great. So now let's do a bit more of exploration of the graph. Let's say I want to find all the documents that has the word project on them, right? So I want a document, right? So this is, if I do this right now, this will return all the documents in the database, right? And for example, we have project 1, 2. Yeah, so these are the two things that we want to return. So here, because it's a name, you can say project. But this wouldn't really work, because if you do that, there is no document called project. We have a project 1 and we have a project 2, but you need to say something like. So in that case, one way to do it is to say where the dot name, and you do this, which says it's a regex, and you can say a project star. Let's see what this returns. Well, it tells me it's an invalid input, and I just mixed up the order, so you can just go and do that. Now, it also didn't really return anything here. So we need to look into how we can use regex in Cypher. And the way you do it is, oh, actually I have the browser tab here. So you can say Cypher like query. And we can look for like here. Okay, you see, so that is the equivalent of a regex, but then this means that our regex was not correct. So what we can do is we can say, let's say first here 1 or 2. Okay, so this gave us indeed a number. So why doesn't the star work? Let's try to figure it out. So what about this? Ah, here you go. Okay, so the star means repeat that character 0 or more times, but that character was a T, but we don't know exactly what the after the word project it would be. So you say, hey, I have a character, I don't care if it's a number, letter, whatever, and there could be or could not be a character. Okay, great. So that solves that problem for us. And now we can also do like an ignore case, and you can even here say case. So it all boils down to regex in that case. I have my ignore case here. Yeah, so it's a bit weird looking, but it will work. So here you go, and you do this. And now, if I say like projects, here you go. You get all the projects. All right, so you've learned about matching, you learned about variables, you've learned about the where with like the where clause with regex, you've learned about filtering based on properties on the node. So these are 4 things that you should be able to do by now. But let's learn how you can create a document. So you've got create a node. You've got 2 ways. You know what? I'm gonna repeat that sentence, because guess what? That goes also on my Instagram, where I give snippets for people so they can benefit from it. So now we will learn about how you can create a node inside Neo4j. And there are 2 primary ways that you can do that. The first one is using the create keyword. And that goes like this. So create a user, you, and you return the user. That will create a user. Let's give it some properties first. So we're gonna give it a name, live stream, and let's say yeah, that's enough for properties right now. So now if I do that, I will create one that's called live string. Okay, but now let's rerun the same one again. So now we might think that it didn't do anything because that name already exists. But let's look into our users with the name live string. Oh, the return star, by the way, means return all the variables defined. So here we see two of those live stream nodes, right? They're actually completely different. So this one is ID 16 and this one is ID 17. Okay, now I'll show you the second way of creating nodes. And this one is called the merge. And the idea is that merge would check first if something exists before it tries to create it. So here we'll create another user. Again, the name should be live stream and we'll return everything. Okay, notice that we didn't get the green thing that says, oh, created one node. Well, let's query for that. So let's match. So match you user name live stream return. And yeah, there are only two. So merge is much safer way of creating nodes. Okay, now you might be thinking of how can I create relationships between these nodes? Okay, similar thing. You have create and merge, and let's start using merge. I think it's safer and overall better experience because you don't get to duplicate. And if you have an error, it all falls together, so you don't have to like rectify the mistakes afterwards. So here we're gonna merge another user, but we're gonna give them a name. That sounds like liver. Yeah, okay. We're gonna name him Hunter. And we want to create a relationship with another node that does not yet exist. Okay, so you might be thinking that you can just do this, and here the relationship, you can start naming it friends or friend with. Let's name him Johnny. I don't know. Or spell Johnny like that. Now return all. So here we're gonna have the user. Actually, let's give it as H for Hunter. And here we're gonna name it R for relationship and J for Johnny. And that did work. Okay, but now let's create Hunter 2. Or random name generator. Let's have some fun. Generate name. Waltoof. I don't know what the hell that is, and I apologize for that weird sounds. But so now, if you have that Waltoof, and you try to connect it with Johnny, let's see what happens. So that is now friends with Johnny. Okay, but what if you have actually, let's just get all our users now. So match So we've got the two live stream, we've got Hunter, and we've got Johnny, we've got Walthoof. But I don't know if you noticed this, but now you have two Johnnies, right? So the two live stream, two Johnnies, a Hunter, and Walthoof. And here's what happened is like when you ran the previous one, yeah, it doesn't show the history. It's okay. Yeah, so when you ran the merge and you said user and you said name is Hunter, connect friends with, and you did this relationship, which is Johnny. Of course, that wouldn't work. Return all. So when you did, again, we did it again, right? So when you do that, you're actually creating new nodes. And every time you're saying, hey, I have this username Hunter with, I want to connect him with this username Johnny, but you didn't really search for anything. So let's get our users and I'll show you how you can fix this. So match. All right. Again, I'm going to try to like group them. So you see we have, again, Johnny, Walthoof. That name generator is honestly weird to give us like Walthoof. I don't know what the hell that is. So yeah, so these are everything that we created, right? But the Hunter to Johnny here, I just want to show you something, right? This is 19, this is 21. You can like even see these are like all created fairly now. So now if you want, let's say we want to connect Hunter with Sam, right? They want to be friends. So you can say match user, type user, name Hunter. So now you would return Hunter, and then you also do a match for a user, name Sam. Now you have Sam, and we'll give them the proper variables. Now we can say merge Hunter to becomes friends with, and we give it a direction, and we say Sam. And here is our relationship, and we say return all. So now we see Hunter is now friends with Sam. But I can run this as many times and it wouldn't create anything new because it already knows that Hunter and Sam have this relationships of being friends. Okay. So we've learned a lot by now. Now let's figure out how we can remove, well, no, before we remove, let's set more stuff. Let's learn how we can find a node and add more properties to it. So we will go and create for all, like for Hunter, let's set more properties. So now you've already created him. So you cannot just merge the properties again. You cannot recreate the node. What we can do is set, because that's what you want to do. And you'll say h dot, let's say, age, right? And let's say Hunter is 21. And we will return. So now if I click on Hunter, I do see the age here. Okay. So now let's say we want to create that for literally all our users. That is not reasonable to do, but let's say I'm trying to think of an example where you need to do that for all users. But before we get there, let me show you another thing. Let's say you want to set Hunter as on a free trial. What you can do is you can say set H free trial. And I don't think that would actually... So here you go. I was gonna say, I don't think that was the way to do it because there was another way, but that's okay. So you have here the free trial created to the user Hunter. Now, if you look at the relationship, so friends with Sam. Right, so S user. So let me get this relationship between Hunter and Sam. So hunters are friends with another user. And the reason why, let me just show you something. The reason why we only got Hunter, because we're returning Hunter and the relationship, and we're not returning the end node. So I'll say you, and now I will see that. And that's exactly what I want. Let's say Hunter and Johnny are no longer friends, and he wants to block Johnny. Okay. One way is to add another link, another relationship that says block, but we might as well just change this relationship here. So now what we can do is you have multiple ways of doing this, right? If you want to create a new link, then you will have to match Hunter and Johnny, and then you'll create a new relationship with the merge command. Okay? But if you want to change the relationship, what you can do is that you can do it like what we're seeing right here, which you say name Johnny. You know what? We'll make Hunter block both Sam and Johnny, and just to learn both methods. So now I have access to Hunter, relationship, and Johnny, and I'm gonna name Johnny as J so we don't get confused. And now I can say set R to block. Okay. So here it says that it was expecting a node, but it got a relationship. So now we need to figure out how to do that. Let's try the second approach first, and we can update it. All right, so here we match Johnny. And let's return everything. So we've got Hunter and Johnny. So we see this here. Now let's see if we can set so that still complains. So we can go to the Lord and Savior, Google, and ask editing relationship in Neo4j. And if you do that, you'll discover very quickly that you don't actually, like, you see, you cannot directly change a relationship type. So what the hell can you do? Okay, well, what you can do then is you can say delete R. So now you wouldn't have any relationship, and you can say merge Hunter blocked Johnny. Right. And of course, I forgot to add the term here. And that wouldn't return anything, of course. And now we actually messed up. And the reason being is now Hunter and Johnny, you see, Hunter now has blocked Johnny, but when we tried to like return it again, we couldn't really get it because that's what we had. And here we're specifying friends with. We should have specified blocked, but even before that, we're deleting R and merging. So I thought we messed up because I thought we had this as blocked, and if we did, we would have messed up. Let's mess up. Okay, it says created one relationship, deleted one relationship. And that's the beauty of the merge, because every time it will double check that you are in okay state. So here it said, oh, you deleted the blocked, but I'm gonna go ahead and create it because that's what you want and it doesn't exist. Great. So now Hunter deleted Johnny and he's friends with Sam. So now let's look into the other way of making him blocking Sam. So we'll do match user. And here's name Hunter. Habits. And we'll match the other user, which is Sam. And now, oh, actually, that was the older approach. So now let's look at the newer approach. The newer approach is you say is friends with Sam right here. And now I'm gonna delete R and I'm gonna merge and the node Hunter to be blocked to the node Sam and return everything to me. So now Hunter has blocked Sam and Hunter has blocked Johnny. Okay. Now let's say we have all our nodes and we need to add to all users to be like early adopters, right? So what can we do? So here we can match first. Let's match all our users. So these are all our users, right? What if we do this? Yeah, let's do EA for early adopters. So now all our users have an early adopter. Okay, now let's do something a bit more interesting for a second. Let's say we want to match all the users and we want to loop through them and do some other fun stuff. So what you can do is you can match your user and then you can say for each let me grab the example. So here, so for each user, in users, right? This is our users right here. But we still, this is a bit broken because where this users came from. So now that you matched all the users, you want to say with collect you as users. And here you're saying you got all the nodes for me after you matched them. Now put them in a collection. So make them an array essentially, right? And you say as users. Also, it's a convention that we write things as uppercase that are internal to Cypher. So now for each user in users, let's say we want to add an let's see. Let's change the first letter to become an uppercase letter. So you're gonna say user dot. So actually we're gonna say set user dot name equal. Now we need to make it an uppercase. You have an upper. I think it's called uppercase. So yeah, it's called upper, just not. So if you do that, right, user dot name, now we should have all the users with their entire name being uppercase. Okay. So it says you is not defined. And of course it isn't now. And the reason being is that when you do a with, you lose the context of the match, right? So if I want you to be available, I'll just have to specify like comma and specify my variable. So now things will become in my scope. And now it's complaining about the upper function, right? And the reason why, let me see. Neo4j uppercase. Oh, it's called to upper. My bad. I think that should work now. Yeah. So now look at this. Everything became uppercase. But that's not exactly what we wanted. We wanted only the first letter to be uppercase. So what can we do? Okay, now you can start thinking a bit more into the programming world, right? Typically we get like the first index of the string, change it to uppercase, and everything else make it to lowercase. And we have substring function here, which you can say user dot name, and you can give it a substring. But let's actually go and look into their documentation. So it takes the original string and it takes a start and a length and it would sub it. So here's the username. We only want the first character. So yeah, we only want the first character. Actually, just to make sure that we're doing it the right thing, let's just lower the first character. And of course, we messed things up extremely badly here, right? And why we messed it up is because we set the username to just their first letter to lowercase. And bam, right? And that's why you should always have your database, one, either backed up, and two, you never really work on your production environment or things where you might lose data to a query like this, because now we're exploring. Now we don't care. Like, we will create all of these again. But if this was a real system, you just changed all the users to just a singular username. And by the way, in reality, and we'll look into that, not today though, but a bit later, about adding constraints. So you can add constraints, which kind of says like, oh, a name could never be a single character, for example, and names cannot be empty, and each ID should be unique. These are all called constraints, and the database would enforce these for you. All right. So now, let's say we want. So yeah, we were able to get the first character. Actually, we should have started at 0, so it's 0 indexed. So if we go back and we read this, an expression that returns a string. Okay. Now the start is an expression that returns a positive integer, denoting where this string will begin. And you have the length, which is where it ends. But if you look here, it starts as 0, so the substring begins at 0. Okay. And of course, I'm not really aware of any undo operation here. So that's pretty much what we have right now. Yeah. So now let's try to delete all our users. So I'll match you, user, delete you. So we have 10 users, we're expecting 10 delete, but that's not what's gonna happen. And here it's complaining that they have a relationship. So to delete this node, you must delete its relationship. Okay, how can I do that? Well, I can use the attach. Detach? Yeah, detach. And then I can do delete you. Invalid input you, expected delete. Right. So here you're saying you can't deattach a node, but you can delete a node. So here you can say I want any relationship with any node. Back to simple ASCII art. So here you deattach the relationship and you delete your node. Okay. You can actually just say delete the relationship and delete the node. So now actually there's something interesting that we did, is that you notice that we only deleted 8. We had 10. And that's the reason, is some of them didn't have any relationships. So let's go and explore who are these who are hanging around into our database. So we've got these 2 nodes right here hanging out rent-free, and we don't want them. So we will actually, here's what we're gonna do. Let me just grab this. Okay, here's what I want to do. So first off, I want to get this node with ID 17 and change its name. All right. So how would you do that now that both nodes are with the same name? So they are your only left hope is to use that ID. And if you go and you use ID 17, you get nothing, because here these are our own properties. And as I said earlier, that this ID is an internal ID for Neo4j. So the way you do that is you say where, and you say ID, and 17. And we must be doing something. So, sorry, you say where ID of the user is equal to 17. And here you go. So to get the internal ID, you need to use this ID function, and you have to pass it the node or the relationship. So you pass it an entity and you say the value that you want. So let's set their name to Carla. And now let's again get that other user. And again, we'll set the ID, I believe 16. So user equals 16. Set u.name equal to Johnny. Papa, what is it complaining about now? Yeah, we're saying set, but we need to where. Great. So now we have Johnny and Carla, but I want to do something more because I want to make sure I drive this point home. That's first match for C, which is user with the name Carla. And let's merge C with friends with and we'll create a new node. Let's create a node called H, and that will be a user. And or actually, let's create a document with name Carla's doc. And here, of course, it's not going to be friends, it's going to be created. And we'll give it a relationship, and we want to return all. Okay. So why did I go through this hassle right now again? Because I want to show you how to delete everything like what we did earlier without leaving these two behind. Okay. But first off, let me check something here because I want to make sure that I'm driving this point home. All right. So now let's say I want I want to show you something. What if you do match and you do a user, and we know that they're a user. We also know there is a relationship, but we're going to say there could be any number of relationships. And it could be any type of node that is connected to this user. Now, what happens if we do detach? Delete. And we delete the relationship. So here we get expected a node, a path, or a relationship, but it was a list, right? So if I do now the user instead, so we deleted one node and one relationship, which will just be Carla. So we only have Johnny. So again, I'm gonna merge Let's create Carla again. And here's what we gotta do. I'll show you how to delete them both in one go. Okay, great. So now I have Carla and Johnny, so we're back to our normal state. And now we want to be able to delete both of them at one go, right? And we have got multiple options here, which is you can either match the users and you say, give me a relationship, any type of relationship, and connect it to any node, right? And then you say delete, sorry, I actually say match, so you can say delete R, U, and U2, right? So that is one way of doing it. Let's run it, and then I'll recreate Carla again. Let me copy this. Bam, because I just don't want to like keep typing the whole Carla thing. So, okay, let me copy these as well. All right, so let's look into this approach. So now if I match I don't have any. So that approach did indeed work, right? So you say, hey, a user, it could be connected to anything, and you can actually put even the star to make it a bit more generic. And you say another user that just like floating around. Okay, I want to show you the second method before we wrap up. So now let's create Carla and the node again. And let's create our boy Hunter. Great. So now if I do match users, we've got Carla and Hunter, and Carla is connected to something. So your other approach to deleting this is you say, give me a match of any user, and what I want is to deattach delete, and you put your node, and you deleted both nodes. So deattach, so the delete you would actually try to delete the node itself, and when you delete the node, you delete its relationships. So if you ran this earlier, and as of we've seen, just delete user, it will say, no, I can't. So again, let's create Carla again. So Carla has a relationship. Now, if I try to just run this without the attach, see, it still has a relationship. So the attach, it attaches the relationship and deletes the node, right? But is that really all of it? Well, let's get our documents and see if Carla's document's still there or not. And let's do the like. So here we have our question mark I anything Carla dot anything. And we just simply need to, is it this order? Okay, it says that there's no documents, but I'm pretty sure there is. So our regex seems to be pretty whack right now. And what we can do is we can put the question mark exclamation. Okay, let's look into all the documents. I see Carla's here. So what was up with that? CAR. Oh yeah. Car. I wrote Carla. And Carals. I wrote some pretty wild names for that. So now it's still complaining. Interesting. Yeah, I always hated regex and I always will hate regex, but let's try to figure this out. So we have these. Carlas, so CAR, so we should find at least two with the name CR. So where document dot name is equivalent to CAR oh, it's really can't find this, eh? So question mark exclamation dot any. Yeah, I'm not really sure why it's not able to match it, because clearly we found it here. So we're saying anything like Carla's underscore dot slash. Okay, so that matches it. Now, is the lowercase maybe? Let's try this. Yeah, I'm not really sure because again, this should really work. I'm a bit confused. I'm just trying to look into the ignore case scenario again that we looked into earlier. That's literally, is that different than what I have? So this is mine. This is theirs. Mine. Theirs. And it's a question mark I, and for some reason I've been putting it the other way around. Damn it. All right, so yeah, here is all of Carla's documents. So the attach didn't actually delete the document itself, right? And just to be triple sure, here's what we're gonna do. We'll create Carla again, but rather than Carla's note, we'll say Carla document 1, 2, 3. Great. So Carla now has a document with this name. Let's copy it. And now let's do the whole match name for Carla, and we'll the attach delete. Attach delete Carla, and also now we can match that's a D of type document with a name that we already have, and let's return document. It's saying that we need a width between these two. So here is what I'm gonna do. I'm gonna match the document first so I don't use the width. Then I'm gonna match the user Carla, delete her, and the attach, and see if the document still exists. And indeed, the document does exist. Again, if we run that, you can easily see that here, right? So if you want to delete the user and everything they own, you just simply have to do a match operation. All right. There is one last thing that I want to show you, and then we are done with learning Cypher. So now I created Carla again, and with her document, right? Or yeah, Carla's now. Great. Now, there's this concept of a path, right? Which you can like return the full path of something in Cypher. So you can say match, for example. Now you're gonna say, I'm gonna name it path, and I'm gonna say this is a user. name Carla, and she is connected to something. I'm not really sure what that is, and it will just be any node. Now I want to return the path. So you can see the actual path here. If you look into, let's look at it as a table, right? You would get the property name Carla of type of the label user, and you'll get the document called Carla's node, and you've got the relationship, which is of type created. But you can also now do delete path. And notice that you deleted both Carla and the node she's connected to and the relationship. And that was the third way to delete something. So you looked into double match and delete. You looked into a single match, detach, delete. You've also looked into finding a path and deleting the entire path. So you've learned about creating nodes in Neo4j. You've learned about adding properties. You've learned about updating properties. You learned about for each. You learned about with. You learned about deleting. You learned about the path. You learned about the basics of the ASCII art as well. Oh well, so that would wrap it up for today, because really today I wanted to get you acquainted with Neo4j. But actually, yeah, before we call it a day, let's look into our own model of that. So now that you understand these things, I don't have to over-explain them anymore. I can just go here. Let's do a large, and then this is going to be our user. And our user will have a document, but by default, we will give them a root document. So this is going to be our root document, which is just a document, by the way. And these would have documents. So they will have multiple documents. Okay. So now the user is actually connected to this document right here, which we will give it the relationship has, and this document will be created by default the moment we create their user account. And we actually did simulate that into our own repository right here in the in-memory, where whenever we say new in-memory repository, we have an inode table with the root document, and that's exactly what we're doing this here. And if we discover later that we don't really need the root document into the database and we just need it in our conceptual model, then no problem. Refactoring this is extremely easy. So now the root document would have access to all these documents, and a document can include sub-documents. So we're actually gonna be building our document tree like this, right, in our own database model. You might be, and okay, so we might say, why not just like have the user created document, and so on and so forth? Why do we really need that root document stored into the database, right? And my quick answer to that would be, it might be very helpful that we add certain restrictions to the overall access. So we can say like the root document, the user is the owner of it, but some other documents below it is actually owned by someone else and shared with you, for example. So the root document kind of acts as like a catch-all, that whenever you want to apply like globals, I think it would be a great place for the root document to be used. And if we discover that we really don't need it again, it will be as simple as like get all documents that are not of type root and just change the relationship directly to the user. So it's no problem. As usual, I usually wrap up by showing you a few things that we will be discussing next time. So next time we will be writing our actually Neo4j connection to the repository, which means that as we have an in-memory repository here, now we're going to be using the Golang Neo4j driver. So Neo4j for Go developers, you can see that there's a driver here, and that's actually officially maintained by Neo4j, which is excellent. And by the way, this is a very, very beautifully written driver, in my opinion. Like some of the most interesting Go code that I've definitely seen. And yeah, it will be quite an experience. And we're not going to be just using execute query. We'll be using like the transactional model, and they make it extremely simple, and they manage shit ton of stuff for you. So it's actually pretty damn nice. As usual, I look forward to seeing you next time, and good night.